Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be tackling this fidget cone design in Plasticity. Now, I've already done a video on this in Fusion, and I did have several requests of people wanting to see this done in Plasticity, asking if it could be done, and let's just go ahead and do it. It's pretty straightforward, pretty easy. This will be very similar to the Fusion video, but we'll obviously tailor it to Plasticity. But let's first talk about what this thing actually is. It's pretty simple. It's mainly a helix, a solid body that's a helix that threads its way through another body. Now, the cone part of this is really just what makes it look unique, but at the core, really what we have is just this helix body. So we're going to talk about how to model it, how to build it, we'll 3D print it, and we'll play around with it. So I'm going to go ahead and get started with a new file. I'm going to delete this cube, / to zoom in. And then now we can begin creating the size of our object. I'm going to be using shortcut keys, and of course I'll call them all out. But if you've never used Plasticity before, I think that you should check out some getting started content that we have to make sure you're comfortable with the user interface. I will call out all the shortcuts. We'll talk about what we're doing. But if you've never used Plasticity before, this might be a little quick for you to follow. So the first thing we're going to do is we're going to hit 1 on the numpad to go to our front view. As a new user or a laptop user, you can also click on the front section of the cube, which is the XZ plane. Then we're going to use our line tool. I'm going to start at the origin, and I want to figure out how tall I want this thing to be. So I'm going to go ahead and hit Tab, which is going to go to my dimension dialog, and let's make it, let's say 50 millimeters. That'll be okay. And then I'm going to use the / to zoom in and zoom out a little bit because it gets kind of crazy. And we're going to go ahead and figure out what we want the diameter to be. So another line tool, we're going to hit Tab, and I'm going to say 25, which will make this thing 50 millimeter diameter. From here, we're going to make the cone part of it. So I'm going to start with the line up top, and we can use, again, Tab, and you can drive the shape of this, let's say 10 millimeters, and then now we want to finish this off. Now, I'm hitting Enter every time to finish off those dimensions. You don't have to. We could model this entire thing if we wanted to. If we're not really worried about precision or using precise inputs, it's pretty easy for us to just quickly model this cone. And what we're going to do is select everything, and we're going to hit J to join. So J to join can also be found down here if we want to join things together. But for the most part, I use J as a shortcut key. Now let's select the profile. We'll select Revolve, and then pick 2 points on the vertical line, and right-click to accept. I'm going to keep the sketch or the curves around, but I'm going to hide them. And now we've got our starting point. Now, before we go any further, I want to duplicate this. So you can use Shift-D, or you can select Duplicate Object, right-click, and then hide the duplicate. Now, the main reason for this is because we're going to cut away from the inside. And then after we cut away from the inside, we're going to use that body and only get rid of the outside of our duplicate cone. So this is going to be the overall outside shape. And now we need to figure out what the inside, the sort of helix, is going to look like. I'm going to do this on the bottom, and I'm going to start by selecting the bottom face and using the space bar to create a temporary construction plane. Now, one of the reasons I do this is because it gives me this profile automatically, makes it a little bit easier for me. Next, I'm going to go ahead and create a circle. This is going to be on the y-axis, and notice that it's kind of hard to snap to it, so you may need to move around until you find it, and then we're going to make a circle. I'm not going to worry about dimensions for this, but the main thing that we want to think about here is how close we are to the outside edge. The closer we are to that outside edge, the sooner we're going to cut through that outside cone with our helix. So we don't want it to get it too close that there's not enough material there, but we want it close enough that it gives us a pretty unique shape. Next, we need to deal with a couple lines. So this shape is going to be the main piece that is part of our helix. And I need to figure out where I want to trim it. So I'm just going to draw a horizontal line and cut it off kind of in this area. We'll use the trim tool, get rid of that. I don't even need that. And then we'll hit escape. Now that we have this, I need to figure out how many of these twists or instances I want. So what I'm going to do is I'm going to start by making a vertical line. It can come to wherever you want. It doesn't really matter. And I hit escape, sorry. We're going to go to here, right click to accept. And then with this line currently selected, we're going to rotate it. So you can use R on the keyboard, or you can select rotate. Down in the bottom right-hand corner, we need to change the pivot point location. So that's V on the keyboard, and we're going to put it right at the origin. So from here, we want to rotate this out. And the reason we're rotating it out is because we only want to model whatever. So if we're going to repeat this 5 times, we only want to model a fifth of it. If we're going to do it 4 times, we want to model a quarter of it. So what we're going to do here is we're going to say 360 degrees, and I'm going to do 5 instances in this case. So I'm going to say divided by 10. Now the reason for that is because this is going to be half. So we'll hit enter to accept. We'll use mirror and mirror it across X, and then right click to accept. So at this point, I'm going to hide the solid body to make it a little bit easier to see these curves. But basically what we need to do now is we need a tangent arc to come down and attach to this shape right here. So on the circle tool, hold down the left mouse button, come down to tangent arc, select it here, and then just pick where you want it to be. It doesn't have to be precise. The main thing that we need is a tangent with that circle. So we'll right click, and then we're going to mirror that. So again, mirror tool, across X, right click to accept. From here, we don't actually need these lines anymore. If you want to keep them, then I suggest trimming them. If you want to get rid of them, then we can just simply select and delete them. I'm going to hide them for now, just in case I do end up needing them. And then we're going to select these 3, hit J to join them together, or you can click on this little icon here. And then we're going to do a circular pattern or a circular array. So when we look at this, notice that we've got the radial array tool, and all we need to do is snap to the origin and enter the number that we want here, which is going to be 5. Now when we do this, this should give us a single closed profile. So that's exactly what we're looking for. If you want to, at this stage, we can join all of these together. So if we select them all, hit join, this should make one single closed profile. We'll hit X to get off of our construction plane, and now we've got the profile that we need for our sweep. So the next thing that we need is we need a line for it to sweep along. For this, we need to make sure we remember how tall the cone is, because we need to go at least through that. So I'm going to use the line tool. I'm going to snap to the origin, and this line needs to come up at least 50 millimeters. I'm going to go ahead and do it taller at 75. And the length of this line actually does have some implications on what we're doing. And I'll explain that in just a second. So we're going to take this profile, make sure that we're selecting the profile. It can be a little tricky, so make sure that you do see the inside shaded and not the outside. Otherwise, we're going to create a sheet or a surface. And with that selected, we're going to go to the sweep tool. We're going to sweep along this line, and then we're going to give it some twist. All right, so the twist value, in most cases, you want to go at least 180 degrees. You can go 360, depending on the distance that you're going. So for example, we could do 360. What you need to be careful with here is the angle of this helix. If it gets too steep, or if it's past 45 or 50 degrees, then with an FDM printer, you start to have problems. So you need it to twist something, but it doesn't need to be extreme. So this is very easy to print here. 180 degrees will work fine. Again, 360 works okay. Past that, then you start to have issues with the sort of the layer lines building in awkward places. In some printers, you can get away with it. In most printers, I would just caution you unless you're very familiar with those limits. Then we're going to right click to accept. I'm going to hide those curves, don't need them, and bring back my original cone. And again, because of the location we put that original profile, you can see where it's cutting through the cone. Now, at this stage, there's nothing fixed in terms of the dimensions. So we could take this cone and we could scale it up if we wanted to. So I could say SS and scale it up, and we could sort of pick where we want that to come through, and then we can duplicate it again. So you can play around with this even at this stage. I'm going to run with this and see what it looks like. But we're going to select the cone first. We'll go to Boolean, and then we'll remove the helix and right click to accept. I'm going to turn off X-ray because I don't really want to see it right now. So we need to make sure there's enough material here in these corners. If there's not, then we're going to have a problem when we print it. That looks pretty good. I'm going to bring back the other cone. Now we want to take the other cone. Again, Boolean. We're going to remove the outside. this time we want to make sure we keep the tools. So now we've got two pieces. We've got the outside piece and we've got the inside piece, and they perfectly match each other. The problem that we have here is we can't print things that perfectly match each other. They'll never slide freely. So we need to use at least a 0.4 millimeter gap. If you do anything tighter than that, you're probably going to have a really hard time. Another quick note, if you make the angles steeper, so if we did 360-degree revolution, for example, then you are going to have a harder time sliding these things together. And the main reason for that, again, it comes down to the angle of those layer lines. The steeper that angle is, the less smooth your part is going to be. So it's going to have those problems. So now the issue that we have here is we need to create a gap. And if we do that by selecting faces, and I'm going to come in, I'm going to hold down Shift, select all of these inside faces. I'm going to rotate this around, Shift, and then we want to go down to the bottom, make sure that we got everything, which we don't. So hold down Shift and work our way around. So the problem that we have here is if we offset this, let's go ahead and do minus 0.4. We then are getting this section quite a bit thinner. So it could start to produce some problems. If we want to offset the other one, so for example, hit Escape and bring the other part back, we can select these, same process. I'm going to go ahead and hold down Shift, work my way around, and let's grab all of these and grab those. And then we'll also need to make sure that we're taking these outside faces as well. And anywhere there's like a little line like this, you need to make sure that we grab it all. Just kind of rotate this thing around. All right, and then we're going to do negative 0.4 on this. So now if we bring the other one back, we should have a small gap here. So far, so good. Everything should work now, but there are a couple of other things that we need to be aware of. So with this design, especially if you did more twists than 180 degrees, you're going to want to add a small chamfer to the bottom edges here. So I'm going to change to an edge selection, and I want to pull this in. It looks like that's a fillet, so let's go the other way and just work my way around. I'm going to have to hit Control and add these edges to the selection anywhere there's not tangency. So once we get around some of these edges, there's a sharp transition here. We could go in and add a fillet and blend that there. Honestly, it doesn't really make much of a difference as long as we can bevel those edges. We can also do this on the inside part. So again, you will need to go across all of the different seams because there are those hard transitions. Let's see if we got them all. Yeah, and this should still 3D print just fine. It's 45 degrees. If you make it too small, then you might not have the resolution to make that happen, but this will make sure that they slide in and out of each other quite a bit easier. So right click to accept. We're going to go back to our all selection, which is 5 or tab on the keyboard. And I'm going to hit / to zoom to fit. And there we go. Now we've got our part. So the next thing that we need to do is actually print this and make sure it works. You could do a print in place like this. I suggest, because I've done a few of these, I suggest not doing a print in place model. So I would take one of them and use move, and let's just move it in the Y direction and just put them next to each other and print them like that. Based on your print settings, you may find that you get a lot of stringing happening between these two. You may need to refine some settings a bit, or try print in place, see if you can print it together. But what I've found is that even when we have a good enough gap between these two, even though we make the angle not quite as steep, what I found is that the bottom edges tend to need a little bit of work. You'll have to move these pieces together in and out just to clean it up a little bit. So make sure that you do understand that if you print in place, they may be permanently stuck together. You may have a hard time getting them out. But with only doing a 180-degree twist on here, it'll be a little bit easier. And the settings that we use, that 0.4 millimeters, that should give us plenty as well. So with a design like this, when you go to export, we want to go up to our file and export options and pick, let's see, STL or OBJ. really doesn't matter. It just kind of depends on what your print slicer will take. I'm going to do an OBJ in this case and say save. And the main thing that we want to focus on here is the options that we have for STL versus OBJ, for example, are going to be different, but we want to make sure that we identify an ideal number of mesh elements. So you can't have too few, especially with these rounded parts, because then they just won't fit. It'll be like trying to push two staircases together. So make sure that you do play around with these options. I'm going to hit cancel, and I'm going to go up to my file, save as, and use an STL. Actually, sorry, file, export, and pick STL. And then we will go ahead and see here that the density slider really should probably be kicked way up. It defaults to 0.5. And in most cases, when you're dealing with rounded parts like this, especially ones that need to fit together, you're likely not going to have enough resolution to make this slide smoothly. So if you're doing an STL, you probably want to kick this up to 1.0. If you're doing the OBJ, then you'll need to play around with some of the options. If you can send a step file directly to your slicer, that's probably the best option, and I would go with that. But again, the density, you probably want to kick up to 1. It's going to be much more dense if you're using the OBJ model and you're using the tries option here. But again, that's good. That's what you want to do. So from here, you would take it to your print slicer. I've talked about this in many other videos. I have a K1 Max that I use, and I'm using an older version of Creality Print. I just prefer that for my own workflow. And I currently have some Creality CR Silk material in. If you've ever used this material, honestly, it's not very good. And I say not very good. It's not very functional, I should say. It's perfectly fine in terms of getting a 3D print out, but you do need to run it a bit slower, and it doesn't quite have the same properties as some of the newer Hyper PLA materials. Or if you're going with another material type, then obviously you need to use that. But the main thing that we should focus on here is making sure that we understand that we don't need any supports. So if we slice this thing without supports, it'll print just fine. If you end up doing your sweep along a path with more than 360 degrees, then you might have to start worrying about supports. And if you get to that point, I would strongly suggest you reconsider the geometry, because you do not want supports on a model like this. But you can see as we go up, even though we've got these angles, it's just going to build each layer as it goes. It's going to be using supports on the inside with, well, not supports, but a pretty sparse infill. At least in this case, I do about 5 to 10%. And that's perfectly fine for this. These arms on the external piece, especially if you have a fairly low infill value, they're going to be pretty flimsy. So you do need to be careful, especially since we cut it out so low on the bottom. So you may find yourself going into your infill options and maybe increasing this to say 15 to 20% just to make it a bit stiffer. That would help those pieces out. It'll still work fine. I haven't actually broken one of these things yet, but they do tend to flex and move around quite a bit more on that 5% infill. So play around with your own printer, your own settings. But this one that we built here with the 180 degree twist over the length of it, this one actually works pretty well. It's pretty good, pretty easy. But let's take this one off to the 3D printer and let's go ahead and check in once we have our results. So I printed a few of these things. The first one I printed, the printer actually tossed an error at the very end for some reason about the extruder temp, but everything else printed fine. So I printed a second one just for good measure. As I mentioned, this CR Silk material doesn't really give the best results compared to some of the Hyper PLAs that are out now. So keep that in mind, that if you are using a lower grade PLA, you're not going to get as good of results in terms of the quality. If you really want to get fancy, you can take your layer lines down. I'm using a default 0.2 here, but you could take them down to 0.15 or 0.1 or something like that, and you could get a better resolution. But overall, these things work great. They're fun. I keep them on my desk whenever I have a meeting, and I can mute myself just to kind of keep myself occupied. But they're fun to make, they're fun to model, and they're pretty easy, a lot easier than you would expect. So at this point, we've done quite a few of these little fidget toys. I have more 3D printing videos planned. There are some requests for things like containers and breaking parts up that lock together. I've also had some requests about mesh-based car parts for 3D printing, and I have all of those sort of planned out and listed. I will get to them as soon as I can. But any other suggestions, please leave them in the comments. And also remember, if you're looking to purchase Plasticity, we are an affiliate. So if you want to support the channel and save 10%, you can use the code LEAD10 at checkout. As always, thanks for watching, and we'll see you in the next one.